This is lesson 2-4, parallel and perpendicular lines. Parallel lines will have the same slope and different y-intercepts. For example, this is the line y equals 3x plus 5, and this is the line y equals 3x minus 7. If you notice, they have different y-intercepts, but they are parallel and they have the same slope, which is 3. These are perpendicular lines that have opposite reciprocal slopes. That means if one slope is positive, the perpendicular line will have a slope that's negative. If one slope is 3, the perpendicular line will have a reciprocal of 3, which is 1/3. So for example, y equals 3x plus 5 has a slope of 3, and this line is perpendicular to that one, and it has a slope of negative 1/3. Some other examples are 2/3 and negative 3/2, or 0 and undefined. If the slopes are the same and the y-intercepts are the same, then they are the same line, and they're called coinciding. So the choices you have here are these lines parallel, perpendicular, coinciding, or just intersecting, which means they're neither parallel or perpendicular? How do you know what they are? You compare their slopes. So let's start with this example here. How do you know if these two lines are parallel, perpendicular, coinciding, or intersecting? The slope of this line is 2, and after moving this negative 2, I divide by negative 2, I get y equals negative 1/2 x plus 4. The slope of this line is negative 1/2. But 2 and negative 1/2 are opposite reciprocals. So this means these two lines are perpendicular. In this example, we're going to find the slope by using negative a over b, because this is in standard form. So the slope is going to be negative 3/5 for this line, and then I'm going to divide this all by 5 and get y equals negative 3/5 x plus 2/5. So the slopes are the same, so these two lines are parallel. In this example, we're going to move the 3x to the right side so that we can get the slope, which is negative 3. Now this equation is already in point slope form. So the slope is negative 1/3. Now these look like they're related. They are actually reciprocals of each other, but they're not opposite. So they're not opposite reciprocals. So therefore the lines are just intersecting or neither parallel or perpendicular. Now these two lines, after you move them around, they have the same slope. They both have the slope of 2. However, this second line is actually the exact same line as the first line. So while they do have the same slope, they are considered coinciding because they're just the same line. Now you'll be asked to write an equation of a line in slope-intercept form, or maybe standard form, that contains a point and is parallel to this other line. So this is the blue line. I've drawn the blue line here. Now you are trying to find a line that goes through this point, negative 4, 6, and is parallel to the blue line. So I'm going to call the blue line a helper line because all you need from the blue line is its slope. So once you know the slope of the blue line is negative 3/4, and your line is parallel, so therefore it has the same slope. So your line also has a slope of negative 3/4. So the helper line's slope is negative 3/4, so your line's slope is negative 3/4. The point that you are given is negative 4, 6. So now I'm going to use y equals mx plus b and to solve for b. Y is 6, m is negative 3/4, x is negative 4, and I'm solving for b. So I get 6 equals 3 plus b, so b must be 3. So this is the equation of your line. Y equals negative 3/4 x plus 3. And if I graph that red line, I see that it goes through my point and it is parallel to the helper line. Now the next question asks, write an equation of the line in standard form that passes through 4, negative 1, and is perpendicular to x minus 3y equals negative 6. So this is your helper line. I need the slope of this helper line. So I'm going to use negative a over b since this is in standard form. You can also solve for slope-intercept form and get the slope that way. So the slope I find is 1/3. That's my helper line's slope. But my line is actually perpendicular to this. So my line's slope is going to be the opposite reciprocal of 1/3. So that means my line's slope is a negative 3. So opposite because this is positive, so mine is negative. And then 1/3 flips to become 3. So now the information for my line is my point is 4, -1. My slope is -3. I'm going to choose to use point slope form. You could also have used slope intercept. Y minus y1, which is that number, equals m parentheses x minus x1, which is that number. I'm just going to work on that until it looks like y equals -3x plus 11. And then I'm going to move the 3x to the left side because that's the standard form. ax plus by equals c. Now here's 2 more examples. Write an equation in slope-intercept form of the line that passes through this point and is parallel to this line and then perpendicular to that same line. So the slope of your helper line is negative a over b, or -2 over b, which is -3. So the slope of the helper line is 2/3. Since my line is parallel, the slope is the same. So I also have a slope of 2/3. Now I'm going to take the point and the slope and plug it into slope-intercept form. You can do point slope form as well. 3 is the y, there's my m, and that's my x, and I'm solving for b. Now b is a little bit, it's a fraction, it doesn't look so good, but 9/3 plus 8/3 will give me 17/3. So my b is 17/3, my m is 2/3, and I wanted the final answer in slope-intercept form, so this is good. Now, what if it's perpendicular to that helper line? Well, the slope we already found is 2/3. So the slope of my line that's perpendicular to the helper line is opposite and reciprocal of 2/3. So that would mean my slope is -3/2. The point is -4/3, and I'm going to choose to use slope-intercept form. Again, you could use point slope if you want. Y, which is the 3, equals m -3/2 x plus b. Now this becomes a 6